Hi, everyone. Good evening. Hope you all enjoyed the fireside chat with Bob in the previous session. Welcome to our second part of today's topic, the future of battery development and manufacturing. My name is Catherine. I'm an investment analyst at TDK Ventures, and I help our investments in energy and battery space. It is my great honor to moderate today's panel together with our esteemed panel guests. First, let me welcome Professor Shirley Meng from University of Chicago. She also serves as the chief scientist at Argonne National Lab. Shirley's research focuses on energy storage materials and systems. Many of Shirley's work has spun off as promising battery startups, including Noble Electrolyte Company, South 8, and also solid-state sodium-ion battery company, Unigrid. Welcome, Shirley. So glad to have you join us. Next, let's welcome Professor Yan Wang from WPI. His group studies fundamental electrochemistry-based technologies. He co-founded battery recycling company Ascent Elements and also dry coating technology AM Batteries. Both companies recently achieved big milestones. Congrats, Professor Wang, and also thanks for joining Energy Week. Next, I'm glad to welcome Phoebe Wang. Phoebe Wang recently just joined Amazon Climate Pledge Fund as investment partner. Phoebe has over a decade of experience in climate tech investing. She has led 20 investment deals, and in her portfolio, 5 of them are in battery and energy storage space. Phoebe, welcome to Energy Week. We're happy to have Dr. Qichao Hu, who is founder and CEO of SES, to join today's panel. SES is a world leader in lithium metal battery technology. Since its establishment in 2012 in MIT Spacement, SES has grown to be a global company backed by leading automakers and is now listed on the New York Stock Exchange. Congratulations, and so glad to have you here, Qichao. Next, let me welcome Dr. Katharina Gerber. Katharina is a senior director of Lightcap. Sorry that today Linda could not join today's part due to an emergency conflict. Dear audience, please feel free to make any comments and raise your questions to our panelists throughout the event at the chat box on your right-hand side. We'll have our final 10 to 15 minutes as a Q&A session to answer your questions. Okay, now I think we can bring all our guest speakers to the stage. We can start our panel discussion. I think to start our panel discussion, I'd like to get a panelist view, firstly, on the status quo of lithium-ion battery development. We know the industry is continuously making efforts to pursue higher energy density, higher power, longer cycle life, more safety. What exactly are we now with current lithium-ion battery, and what is the best that we have achieved so far? I hope to hear from our panelists. First, to make some comments on the status quo of lithium-ion battery development.
Okay, since I'm the only one who wear the government national lab hat, so I will start by opinion the success of our field. I think lithium-ion batteries world production has exceeded 1 terawatt hour per year production capacity. So it's extremely exciting zone for the 30 years. And in this year also marks the 30 years commercialization of the lithium-ion batteries. So I want to remind everyone that 92 first cell was sold commercially. So I think right now the lithium-ion batteries production capacity is amazing. I think we would expect any new technologies who are working to complement lithium-ion batteries. I would not say replacing, because every time when I gave the lecture, I already emphasized we never replace lead acid batteries. It's still with us. We never replace the metal hydride batteries and alkaline batteries. They all with us. With the new battery technology, we were able to electrify things that we never imagined before. So I would say the new technology complementing lithium-ion technologies will have a very high bar to match, both in terms of production volume, safety record. I mean, if you look at how many cells were shipped out in the EVs, I think lithium-ion cells, regardless what people can demonstrate how dangerous lithium-ion batteries can be, the safety record is actually very outstanding so far. So I think all the next generation technology has a difficult race to go. But at the same time, if we consider we're complementing lithium ion battery technology, I think everybody will win. We have many winners.
Nice, Shirley. So speaking of a more current status of lithium-ion battery, how do you comment on the energy density level and charge rate? Because many people saying, oh, now we can achieve 320 watt-hour per kilogram. Is that really achieving, or is that in pack level, cell level? And also the rate performance, people is saying we can charge in 10 minutes, 15 minutes. How do you comment on these specific data?
If 20 years ago, if people tell me they can reach this 700 watt hour energy density, I would be pretty shocked. But lithium metal can do better. I think Qichao, you need to jump in and say the new technology can do better. Of course, we have limitations with lithium ion.
If you look at the state of the art in terms of lithium ion, we've seen like 300, 330 watts per kg, and then 800 watts per liter lithium ion cells. And these will have high nickel cathodes and then some type of silicon based anode. But to Shirley's point, it's about the technology, but also it's the capability, right? New companies versus, say, CATL, LG. Technology is one thing, but it's that capability. They have everything. They make their own cathode, anode, electrolyte separator. We make everything, you control everything. And then at the end of the day, the cell is a system, not just a combination of individual technologies. So if you control everything, if you have the capability to make every component, then you really have the ability to optimize the whole thing. And I mean, energy density, charge rate, we've seen 1C charge and 1,000 cycles, 15 minutes, 20 to 80%, 10 to 90% state of charge. Lithium ion is really hard to beat. But I think there are these new generation technologies like lithium metal, like recycling, that don't completely change lithium ion, but basically stand on the shoulders of lithium ion and then ride the wave of innovation of lithium ion. So all the work that's been done in the field, in the cathodes and manufacturing process, we can leverage that. So it's not completely disrupting lithium ion, but ride the wave of success of lithium ion.
Cool. I'm actually also, I agree with Qichao and also Shirley. I think right now we do have progress, but the progress that we have made in lithium ion space is incremental. We have 5 times improvements. We have 10 times higher energy density. So Phoebe, I'm interested to hear from your perspective. How do you see where we are and where we put money to get what we want? For example, let's say solid state lithium metal, how much improvement we can get and how far are we from now?
Yeah, great question. And actually, I think there's still quite a way to go for lithium ion, right? Reportedly, there are startups that can achieve potentially like 450 watt hour per kilogram, which is like a kind of set the record. And obviously, whether they will be able to make that mass production, that's still remain to be seen. But I think there are interesting technology, for example, like kind of replacing the anodes kind of with the current graphite lattice with a silicon nanowire that could potentially store higher density of lithium ion. So I'm still pretty hopeful for the lithium ion batteries, very similar to Shirley and Qichao's view over there. I'll double click on the solid state because I think that's a really interesting space, which could see some breakthrough in the next probably 2-3 years by 2025. So if you're thinking about the lithium ion batteries, you're actually using the liquid electrolyte. And for solid state, obviously, the very big difference is that it actually used the solid as the electrolyte. And because of that component change, and then you use different type of cathode anode, and you actually can get a higher energy density. And because it's not using the liquid electrolyte, you can actually have a non-flammable process for that. So it's kind of arguably to be safer, higher energy density, but there's also like a downside over there. One is right now we don't really see a very clear path of mass production. And also finding the right solid state or solid electrolyte is still pretty much in the science lab. And obviously, we still need to have a lot of technology innovators in the space to help out. But I'm very hopeful for the battery technology development based on what I've seen of the innovators in the field.
Yeah, I agree. I think right now we for sure can make solid state batteries, but right now, if you look at all the supply chain for solid state batteries, especially some of the solid electrolyte, it costs for several $1,000s per kilogram, or even $10,000, more than $10,000 or $20,000. So it's super expensive, and then the platform is not ready. Sometimes you're just lacking the equipment to build a solid state. So I love to hear from our guest speakers. How do you see the timeline that we have for these next generation technologies, lithium metal, solid state, and how ready we are on the supply chain, and whether that is the thing that if we put more money and then we can accelerate the preparedness to have these technology to be commercialized?
So my lab has been working on different types of solid-state batteries, lithium metal batteries. I'm now fully convinced those batteries can replace lithium-ion in the near future. Of course, the higher for energy and power is better, but the condition is that we cannot sacrifice the other properties. Eventually, you have to come down to the cost and the safety, supply chain, etc. Today's batteries actually is pretty good. Now, for some applications, maybe you want a higher energy density. For most of the applications, like portable electronics, EVs, today's lithium battery is good enough. I also heard from auto industry, sometimes they say current lithium batteries in the EVs, they are over-designed. That means like after 10 years, 100,000 miles, those batteries can still have a 90% or 85% capacity or energy left. I'm now fully convinced for pure solid-state batteries can replace or can play a big role in the next 10 years. Maybe I'm not smart enough, did not figure out the solutions, but we'll see.
Very interesting. I actually love to have some debate here. So right now, Professor Wang said, right now lithium-ion battery is good enough for most of the passenger car. However, we're also seeing some, for example, heavy-duty electrification, aviation, and also let's say if we in the future, if we integrate the car to the grid, we might want to not only use the battery to drive the mileage, but also to participate in the day-to-day energy arbitrage, and then that might need probably more than 10,000 cycles of life. I would love to hear from the panel. Is lithium ion really good enough to achieve all these goals?
If I
Catherine,
can,
yeah, you are an analyst. You are actually allowed to express your opinions as well. So we would love to hear your opinions. I think Qichao probably will talk about lithium metal, but let me say a few words about solid state here. I think your question about whether money is the only thing needed to accelerate things, the answer is absolutely no. We will need fundamental breakthroughs in science and technologies in order for the innovation to happen. There's no such things that if you pour a huge amount of money in, that some of those technology challenges will be resolved. I mean, some of you might be too young. In year 2000, when the hydrogen economy is at its peak, and many battery people were always questioned if battery will ever make it into full electric cars. So I would say that the fundamental reason we do solid state is because there is a possibility to have no crosstalk between the anode and the cathode. And with solid state, I believe this is the only way that we can truly make vehicle to grid and really make a battery into an asset for the society, that we will no longer treat batteries. Even with recycling, many people treat batteries as disposables. They don't treat it as an asset, meaning that if you buy a house, if there's a battery in it, it's no big deal. But it should be, because batteries is the refrigerator for electrons. And if you want to keep large batteries at home, the safety is very important. So I think solid state people are actually trying to address some of the society problems, and we should all give them some credit, even though they know the uphill battle to compete with lithium ion. But they have to do it because the society demand us to do it, that you have to find ways to extend the battery life not even say 30 years. Why not 100 years? Many of the utility hardwares are 100 years. And if we cannot do that, we cannot decarbonize the grid. And that would be my 2 cents.
If I can just jump in and talk about lithium metal, I think lithium metal, it's possible to use that for passenger applications. And then maybe we start with like a large SUV, a large truck, or of course, VTOLs, drones, these line applications. So if you were to ask me maybe like a year ago, I'll probably say no. It's super hard to commercialize lithium metal, especially a year ago. We just started making these large 50 amp hour, 100 amp hour lithium metal cells. And we have so many problems, so many challenges. But I think in the past 1 year or so, we and also our partners, we did make a lot of progress. Supply chain, I mean, really the cathode is the same, right? Cell manufacturing process is the same. The anode is really just how you put lithium on copper. The copper is the same, but the lithium, of course, is unique. But that part, we actually made a lot of progress. It used to be quite fragmented, like one company making everything from the mine to ingot, another company purify the ingot, and another company evaporates it or coats it down to foil, and then you have to apply all the unique process to make it into the anode that you want. So very fragmented. Not only not good for cost, but also it's not optimized. Each company will optimize it based on that process, but no one optimized the whole thing. So we took the chance to try to optimize the entire process from ingot down to the final anode. So we made a lot of progress there, and also just a ton of manufacturing issues, like how you even cut anode that size. Do you use a steel die? Do you use laser, powders, particles, all that? A ton of issues. Basically, after going through the same crap that Tesla went through in 2018, I think now it's actually possible. We still have a lot of work to do, but combining all the experience in the pilot line, and then also one thing that's really important is the use of software. I think that is really important because it's probably really hard to prevent this big cell from exploding, and then we have experienced that many times, but it's actually good learning. So each explosion is a data point to train the software. So it's actually important. And then we do a ton of these data training exercise. So now this model is actually a lot more accurate. You don't have to build a whole new supply chain. You just use lithium ion supply chain, except the anode piece. You gotta solve that. But other than that, I think the cost supply chain definitely doable. Manufacturing, cell performance, definitely. So basically, compared to lithium ion, everything at least as good, except the energy density is higher.
Thanks for the input. I think you tackled the point of the AI and algorithm modeling that could really accelerate the battery development. Actually, Bob, in the previous session, he shared that CATL, they're using the same drug discovery algorithm to check out the new chemistries. So this sounds very exciting and promising. I saw right now we have so many new exciting things going on, like sodium ion battery, potassium ion battery, magnesium battery, and even aluminum battery. We are seeing these new breakthroughs on different chemistries every day, which potentially could also solve the high cost problem of lithium ion battery. Seeing right now we have the tool of the new material discovery, we can accelerate the process of the development, and then we have the options to go for cheaper materials, cheaper metals. What is your thought on these new chemistries? Do you think there will be one day they will replace lithium-ion battery? How do you see the development cycles of these alternative options?
Yeah, Catherine, maybe I'll start again. I think all those batteries, they have their unique properties. To me, sodium-ion batteries maybe have a better chance than the other types of batteries. The reason is that sodium is smaller compared to the potassium, aluminum, magnesium, and some sodium-ion battery companies. They are more advanced compared to other types of batteries. To me, still, I don't think those batteries can replace lithium-ion. Maybe they can supplement. Also remember, when you talk about the cost, what's your cost target? Can you reduce like 50% or 80% of cost by just changing the chemistry? The answer probably is no, because the lithium right now in the typical lithium-ion batteries is 9% of the cost. So that means that even you don't use any lithium in the lithium-ion batteries, but you keep all the other materials manufactured the same. but you only reduce like 9%, maybe 10% of cost. It really depends on what's your expectation. It cannot reduce like 50%.
Thanks, Yan. Speaking of the cost, Serena, I hope to hear from your points. So the cost, we have raw material costs and also we have manufacturing costs. So both, I think, Yan and Katharina, you have been working not only on the raw material, but also on the processing method to reduce the manufacturing costs. So could you give us some of your perspective on how dry coating can make a difference?
I think everybody knows in this room that if you look at the battery cost, you can break down that cost of the cell to raw materials and manufacturing. And so raw materials is about 70% of battery cost and 30% is manufacturing. So it's quite a big chunk. And also looking at the supply chains of raw materials and prices of commodities. So the only way how we can continue reducing cost of battery cells is to look at how we make them, what manufacturing processes we use. And one of the largest contributors to cost is wet electrode coating, which requires a lot of energy, large capex expenses, and a lot of solvents. And it's also a fairly long process, so you have to dry your electrodes for many hours. And I think dry coating could really make a big change in the future and also make gigafactories more sustainable and more cost effective because it removes all the toxic solvents from the manufacturing, also reduces capex expenses that are required for factories. And I think another point that dry coating could do in terms of cost reduction, you can coat using dry coating technology so much faster. Like, for example, in my company, you press powders to a freestanding electrode film, and then you can laminate it on a current collector. So it just takes you a couple of minutes, and it would help real developers to do with high throughput experiments and develop new materials faster, because every time you have new cathode material, you have to test it, you have to make electrode. And if you use wet coating all the time, it's quite energy consuming. It's also very inconvenient to deal with all the toxic solvents. So I think from this standpoint, dry coating could do a lot of good services to lithium-ion battery.
Thanks, Katharina. I do have one question for our panelists. So dry coating, we kind of know by removing the solvents, we can reduce the manufacturing cost. So will dry coating technology also work on solid state batteries manufacturing? And Shirley, you just said that it has to be solid. If we putting electronic refrigerator at your house, it has to be super safe. What's our panelists' thoughts on solid state manufacturing and also dry coating integration for the next generation manufacturing?
I think Katharina and I both have said in the public, solid state will go for dry processing, right, Katharina?
Yes, I can also add from my side, without disclosing any partnerships, we work with different solid state material suppliers, and we already have proven that it is feasible. And I think actually dry coating can help to accelerate commercialization of solid state batteries. You can develop cool materials with good performance, but you always need to think, can you scale it up? What tools can you use to scale it up?
Yeah. So in our last year's work with LG Energy Solution, we already demonstrated using dry process for the solid state cathode processing, even though it's in the small lab scale cell. And Catherine, you mentioned about the unigrade for sodium solid state. It's also because we succeeded in the dry process that we decided that the TRL level is higher, because like Catalina said, the processing method is fast. And I want to remind everyone, even in the lithium ion technology, dry process should not be overlooked. It's not just simply for removing the toxic solvent and reduce the processing time. Maybe in 1 or 2 months, we will release the study. We have a scientific study with the binder company who supplied the special designed binders. There are many surprises. For instance, think about how you push the voltage up to above 4.3, 4.4 volts. Is that possible with the different binder? right? And also I want people to really think about the dry process for the silicon has previously been not successful, but I think both Catalina's company and our track record has shown that it's just because we don't understand the science behind the degradation in the anode side for dry process. So there may be possibility that the anode side can also be succeeded with the dry process. So there's a lot of possibilities. That's why I always think it's not a money problem, it's an innovation problem. And we need more people with brilliant ideas to come and do the work that innovate. The only way to keep yourself in the cutting edge is keep innovating.
You need a good design and good understanding.
I agree with what Shirley and Serena said. I just want to add one more point. So in the typical lithium battery manufacturers, roughly 47% of energy is used for the electrode manufacturing and drying and solvent recovery. Also, we know the electricity usage is directly related to the carbon dioxide emissions. So in the US, for example, if you want to produce 1 kilowatt hour electricity, that means you roughly generate 0.7 to 0.8 pounds of carbon dioxide. In Europe, it's lower, maybe 0.4 to 0.5. But like again, if the dry manufacturing is successful, we can also significantly lower the carbon dioxide emissions in the entire battery manufacture, no matter it's for lithium ion or solid state or sodium ion or other types of batteries.
Thanks, Yan. I just realized that right now our panelists, we can kind of divide into two groups. I want to start an interesting debate here. So Qichao, you are representing lithium metal, but using existing drop-in to current roll-to-roll process. And then Yan, Katharina, you're more on the, right now your dry coating will first tackle on using dry processing on the existing electrode processing. So Qichao, what do you think? Your way of using liquid electrolyte, you are still using the same electrode coating technology. What do you need most to accelerate your lithium metal technology with liquid electrolyte? And also, I hope to get opinions from Phoebe and Shirley. What do you think the dry coating or even advanced to entire dry processing to make all solid state battery? What do you need to make it faster?
We're also doing dry coating on the cathode side. Like whatever innovation comes from the lithium ion industry, even solid state, we can also use that. And then if dry coating is cleaner for the environment, then a lot of the cities that we build our pilot line, if you evaporate solvents, it's actually really difficult to get environmental permit. You have to recycle that. So we are looking at dry coating on the cathode side. I think our biggest challenge is really on the anode side. And the cathode, the cell assembly process, all that, we are working with several partners to use the latest process to improve that. But then on the anode, how do you design this lithium? And then how do you make this lithium? So process material so that it can withstand all the lithium plating and stripping, all the mechanical force, all the reaction for hundreds of cycles, and then under very high current density. So how to do that? That's actually really, really challenging. So we are developing new materials at the small cell. And then once we have the new materials, we try to expand these to the larger cell. But then when we started out building the larger cells, there are tons of issues. Okay, so for example, we figure out how to make the lithium anode in the small form factor. But once you scale that up to a large 600 millimeter wide, then it becomes totally different. The material is not the same, the porosity, the morphology, all that changes. And then surface changes. And then how do you cut it? Do you use a steel die? Do you use laser? And the laser burns the lithium and then creates particles. Basically, we have a ton of challenges there. I think what we need is really just a lot of characterization. We have that for the smaller cell because the smaller cell, it's easier to characterize. You can open it at 100% SOC without getting killed. So it's safe, right? But then imagine 100 amp hour lithium metal cell, 100% state of charge, cycled. How do you do tear down? You have to do tear down because if you don't do tear down, how do you see the particles? How do you see the cell design? Okay, you do CT, X-ray, but how do you safely do all these characterization on the cells, these large cells, and then we actually had to develop our own tools, robots, arms, and then all these different ways of doing CTs. And then a lot of the third-party CT tools, we can't fit the 100 amp hour lithium metal battery inside. It just simply doesn't fit. And then we have to take images on parts of it and then piece them together, or just find the one location that has the tools. So I think because the cells are so much larger, and then even if we think we have certain set of performance in the smaller cells, once we get to the bigger cells, we just have to do a lot more characterization. We cannot assume anything. We can't assume, okay, we see this in the smaller cell, and then therefore in the 100 amp hours, we will see the same thing. Actually, no. I think a lot more characterization, and then you identify where the problems are, and then you can solve the problems.
I see. So it looks like not only the manufacturing we need new equipment, new tools when we scale up, but also the characterization part. We all need like very different tools that we're using now when we do the material development. So that actually comes to another question I'm interested to ask our panelists is that right now we see in the US, there's a lot actually blocking us is we're lacking all the equipment. We're lacking all the facilities. We are lacking all these clean production factories or pilots to validate many things that we are suspecting. So recently, the IRA really gives promising signals that right now the US government is putting a lot of tax credits incentivized to support local clean energy, clean production, manufacturing build up. How's our panelists' view on this new bill? How do you see this new government bill will change our battery development and manufacturing in the US? Phoebe, do you want to start?
Yeah, I can certainly start. I think the IRA is definitely kind of music to many entrepreneurs and climate tech investors' ears, right? I think the most recent policy actually have the goal of reducing the carbon emission in the US for the domestic energy production and manufacturing roughly by 40% by 2030. So that's a big goal. If you're looking at all the different clauses and different policy, like for example, the domestic content requirements for EVs. So it all kind of gear a lot of our OEMs and automakers towards internal or domestic manufacturing for batteries. So all these are really good credits to having our battery innovations and battery manufacturers to have more leeways to do the testing, to do the innovation. But again, supply chain is always an issue over there. I have so many companies in the portfolio that need to kind of potentially delay their start date and labor shortage coupled with inflation. So these are goals that we need to go through. But I would say that Inflation Reduction Act would help a lot in terms of smooth out the cost curve and also improve the efficiency through the innovations that our entrepreneurs would be able to bring.
Thanks, Phoebe. How about views from other guest speakers?
I think let's hope the US, this is a once in a lifetime opportunities for many of the manufacturing. This first round is mostly materials supply. So Phoebe, your worry about the supply chain was definitely being, on the top list, priority list of the consideration when they put out this first round. You can see the fund mostly went to the materials companies, right? Companies who are making lithium or metals or silicon for the battery industry. Yeah, I think from our perspective as researchers as well as people who are putting out the workforce, I do want to say the supply shortage is not just materials. We have a workforce shortage as well, because for the last 2 decades, I would have imagined that every top engineering schools will have battery training programs, just like few decades ago with the semiconductor industry, that almost every top universities have clean rooms, and then we have so few universities that have dry rooms. Like a lot of the students actually were put out to the workforce without the proper training that the industry could hoped for. And now, of course, everybody is scrambling to get the talents. I just want to add Phoebe's comments. It's not just the materials, it's the talents also that we have to make sure that it's a healthy ecosystem. where we hope all the industry do well. And then the circle back is that if the industry do well, there will be continuous supplies of fundings as well as talents. And both are absolutely needed for the field to continue to grow.
Nice, Shirley. Professor Wang, please.
Yeah, in order to help the entire industry, I hope just like the support is not short time, because it takes like years to develop this industry. We cannot just in these 2 years, like all the industry, all the government, all the like venture people, they see battery is a hot topic, they invest lots of money. So after 3 or 5 years, they find another topic, then they switch away. That will be useless. I think we need like a span like 10, 15 years in order to catch some Asian countries.
So I think on the IRA, I think eventually it'll come down to a commercial decision for the car companies and then maybe the consumers. Definitely it's opportunity for US-based new companies, but also a lot of foreign companies are also looking at this as opportunities. I mean, lithium ion today is still the gold standard, and then 70% of the supply chain is still in China. And then recently there are lots of Chinese companies, also Korean companies looking at this as opportunity. So there are new technologies, new startups here, but then there are also companies that have very proven operation, proven efficiency, proven cost. What if they just copy and paste? Of course, there are political considerations and then varies state from state to state. But eventually to the car companies and then the end user, how much are you going to pay for the battery pack, the efficiency, the cost with subsidy? I think eventually it'll be a commercial comparison.
Yeah, I think it's really, really amazing discussion here. I think what I learned is that right now we have the policy incentivized, and then we have the largest market to be electrified. And I think probably we're not just going to do copy and paste from whatever Asian already done, but we need to leap forward with new material, new processing, new battery technologies. I think we are a little bit running out of time, but I'd love to show our polling result that we had on LinkedIn to see how people look at future technologies, including silicon anode, lithium metal, solid state, dry processing. I think these are all very good directions how US battery manufacturing can leap forward in this battery game. So operator, could you please pull up the poll results?
Oh, equal.
Yeah. So it's actually a pretty, when I see the dynamic bar changes, it's a pretty tight game. Actually, this is the data that I had a screenshot the day before. And just actually before this event, because I have no time to update the data, I saw alternative chemistries again become the second high vote.
You should
Yeah.
merge dry coating with lithium metal solid state.
Yeah, we should
So
combine.
this is also good for me to also echo what Dr. Wang said. You know, the most critical thing is being consistent about the policy. So I think the electrification does have bipartisan support, and then we have to do a good job to deliver to the society. So as you see from the polling, the winner is not clear. So we have to keep innovating in all fronts. Like cannot just choose winner and lose at this stage. We have to innovate. I think there's so many different people who are having different expertise and they have different views. I think it's fantastic that you can see from the polling, right, that winners is not clear, that we have to keep doing all things in these different directions.
Exactly. I think that's the best conclusion we have right now. The game is just started. All right, I think let us come back to the Q&A. We have collected many questions from the audience as well. I will just follow the most highly voted questions. I think the most popular question is from Ling. He asked, in terms of cost, which one is better, dry coating or water-based ink coating?
I can answer this one. So I think dry coating is definitely going to be cheaper, because even if you have wet water-based solvent, you still need the energy to evaporate with liquids, and equipment is still going to be relatively large. So it will be more sustainable, but not necessarily cheaper.
Thank you, Katharina. Let's move on to the second question from Anil, our investment director. Why it is so hard to go from small cells to large cells? Why do they suddenly become unsafe?
It's a long story. Also, so even the small cells in the beginning, they were not safe. But then over a period of 3 years, they became much safer in process. With a lot of characterization, teardowns, understood what happened. The particle, when you do the large cell, well, one, the software has zero data to start with. So the software is useless in the beginning. And then manufacturing, the cathode coating line is totally different. The anode coating line is totally different. The stacking, the entire line is totally different. It's run on the totally different line. So we have to do the same thing, go through characterization, do teardowns, open up, understand where the manufacturing issues are, address those. We've probably gone through 2 iterations of manufacturing lines. We've improved the cathode, the anode lamination tools more than twice already to improve that. And then the software, now we've built several hundred of these larger cells. And then even the failures, the ones that had incidents, those data are very valuable to train the software. So now it's definitely getting much better. And I think with time, the larger cell should achieve the same performance and safety as a smaller cell.
Nice. Now we have a next question, Pauline. What are panelists' takes on the current and future market of printable batteries? Would you share your perspective on challenges associated with material design?
Maybe I can
Batteries.
jump in here. Yeah, so I think for people who follow me on LinkedIn probably know that I do have a long history working with the company previously known as Z Power, and now it's called Riot Energy, that's specifically working on printable batteries. So I think the printable batteries will be serving a niche market of IoT, which is not a topic we spoke much in this forum. It still is a very important topic in my opinion, because I believe IoT never really took off in the real sense because they don't have a appropriate energy and power source. So I would say that it deserves a separate session if there's a interest in thinking about how printable batteries can change the way how, let's say world logistics are being tracked, because most of the sensors today cannot have power source to communicate, right? So, and also when we think about future autonomous driving, when object and object has to communicate to each other, I think the current autonomous driving using image based processing is not sustainable and scalable, and we will have to think about new ways how to design the IoT and the Internet of Things. Yeah, I think there's a lot of potentials there. It's just quite underexplored right now.
Thanks for the input, Shirley. I want to wrap up the session with asking each of our panelists to give our audience one piece of advice. Let's say if we have a future entrepreneur coming here to say, oh, I want to, since right now with the IRA, with the electrification goal, I want to start my battery startup. What will be the one sentence advice you will give to the newcomers?
Yeah, I can start as a VC investor over here. I think the commercialization is really important because we have seen a lot of breakthrough innovations in the lab work, and then how you actually move from the lab, like the TRL, that's what we call valley of death. So if you can kind of bring your technology, your brilliant idea from the lab to potentially a pathway to commercialization and scale it up, I think it'll bring you to a long way.
Commercialization. Thank you, Phoebe.
Yeah, my advice is don't give up. Co-founded 2 startup companies. There's a lot of up and down. Many people question me initially when I started recycling research like 11 years ago. People laugh at me, say, "How can you get those battery to be recycled? Versus you don't get enough battery for you to recycling." Now, like become one of the hot topic.
Yeah, hold on, Shirley, Qichao.
So I think from my perspective, focus on the system. Eventually, you need to deliver, whether it's storage or automotive application, eventually you have to deliver a whole system, and the technology might change. The technology that eventually you pursue might be different from the technology that you start out with.
Thank you. Systematic level design. Shirley?
I think we're recording, but I will still say it. No matter how hot hydrogen become, please stick with batteries.
Thank you, Shirley. Well, we're going to have a battle between the hydrogen session and the battery session.
Actually, I don't mind doing hydrogen research as long as they do not take resources away from batteries. We are on the upward trajectory in the really, really good trend right now. We need to sustain the growth and try to give hydrogen folks more time to be TIL ready. And I say it with very serious that our talented people don't waver. Battery energy storage is absolutely key enabler for the decarbonization effort.
Yeah, I also think those are hydrogen is more on the industrial decarbonization, producing the green steel production, and then battery will be more on energy storage and then driving the mobility. I think they can still be good friends. All right, Katharina, do you want to close up the advice part?
Yeah, I think I will give you advice Linda probably would give if she would be in my place. So she usually says if you try to make something work, use what she calls KISS technique. So keep it simple, stupid. If you develop any process or something new, just make sure you don't complicate things. Make sure you create a product that can be scaled to the mass production.
I like that. KISS. That's a good takeaway. All right, good. Really appreciate everyone's time. I hope to use the last 1 minute to thank all of our guest speakers today and also our audience today. We have a lot of event partners from very early stage investors on batteries, incubators, VCs, and also partners, for example, our largest battery communities, Boulder Foundation in US, in Europe, and then some of the research centers that are supporting commercializing lab scale innovations. We really appreciate your help. And then entrepreneurs, feel free to get to these resources, and investors, those are places where you can find a good deal flow. And also, we hope to promote and support early stage innovators in the battery manufacturing and development space. These are still growing young startups. Let's put our attention and support to these companies. And then at last, I hope to promote our next day event, which will be another 2 sessions on emerging market electrification and future of EV and charging. I hope we can gather again tomorrow. Thanks again for everyone's time participating in this session. We'll also have the replay available in this platform. Thank you, our dear panelists. Really great learning today. Have a good night.